Hi everyone! For today's video, ang ating topic is yung ating wave motion. So, let's proceed sa ating objectives. So, in the end of our discussion, you will be able to identify the types of waves. You will be able to solve problems related sa ating sound waves and then to compute problems related to wave function. So, let's proceed sa types of waves. So we have two main types of waves. Meron tayong mechanical and electromagnetic waves. Yung ating electromagnetic waves are produced whenever electric charges are accelerated. This makes it possible to produce electromagnetic waves by letting an alternating current flow through a wire. Yung ating electromagnetic waves does not require a medium to propagate. Now, some example ng ating electromagnetic waves are yung ating visible light, radio waves, television signals, and X-rays. So again, ang ating electromagnetic wave doesn't need a medium or yung kanyang material para daanan, kumaga. So it travels through air, ang ating electromagnetic waves. Next is yung ating mechanical waves. So all mechanical waves has some physical medium as to be disturbed. So we have three requirements under the mechanical waves. So first, it requires some sort of disturbance, a medium that can be disturbed, and some physical mechanism through which elements of the medium can influence each other. So next, we will talk about the pulse wave and then yung ating periodic waves. So we have here a animated representation. So yan, okay. So meron tayo dito yung ating wave pulse o yung ating pulse wave and then yung ating periodic wave. So ano bang pinagkaiba nitong ating wave, pulse wave at saka periodic wave? So itong ating both waves, itong pulse and periodic is under siya sa mechanical wave, which is a disturbance of medium which travels through the medium transferring energy from one place to another. Bakit siya under sa mechanical waves? Dahil it requires a medium and then yung ating medium is yung ating material na wire. Okay, so next, let's talk about yung ating pulse waves. So one way to demonstrate wave motion is to flick one end of a long rope that is under tension and has its opposite end fixed. So dito sa ating figure 16.1 yung ating example. So we have first, kumbaga ito yung ating first snapshot. So yung rope is hihilahin mo. So yung ating rope is under tension. Okay? So in this manner, a single bump or if flick mo, isang flick lang ha, yung ating naka-tension na rope. And then yung isang bump na yon is called a pulse. And then yung ating pulse is formed and travels along the rope with a definite speed. Itong ating figure 16.1 represent 4 consecutive snapshots of the creation and propagation ng ating traveling pulse. So under the figure 16.1, a pulse traveling, okay, so next yan na motion, ito na. So meron na tayong pulse. So a pulse traveling down a stretch rope, the shape of the pulse is approximately unchanged, okay. Unchanged as it travels along the rope. Okay, hanggang magdating siya dun sa ating fixed end. Okay. Oh, okay. Wait lang, erase muna natin yung ating mga annotations. So next, we shall first focus our attention on the pulse traveling through a medium. Once we have explored the behavior of a pulse, we will then turn our attention to a wave, which is a periodic disturbance traveling through a medium. We created a pulse in our rope by flicking the end of the rope once. Isa lang. A traveling wave or yung ating pulse that causes the element of disturbed medium to move perpendicular to the direction ng ating propagation. So, this type of wave is called transverse wave. So, yung ating transverse wave is again, yung kanyang direction is perpendicular to the direction or nung ating motion. Okay? So, perpendicular. So, dito sa ating figure 16.2, transverse pulse traveling on a stretched rope, the direction ng ating motion of any element P or yung ating pulse of the rope, yung naka-blue arrow, is perpendicular to the direction ng ating propagation or yung ating red arrow. So next, yung ating periodic waves naman. So once we have explored the behavior of a pulse, we will then turn our attention to a wave, which is a periodic disturbance, traveling through a medium. Compare this with another type of pulse. One is moving down a long stretched spring, as shown sa ating figure 16.3. The left end of the spring is pushed briefly and briefly to the right. Okay, so ang ginawa natin, so from here, okay, from left to right, the left end of the spring is pushed briefly, so nag-push tayo to the right, and then pulled briefly to the left. This movement creates a sudden compression, okay? Nung nag-push tayo pa left, pa right, is meron tayong compression na nangyari. And then, this movement creates a sudden compression of the region of the coils. The compressed region travels along the spring, o yung to the right. The compressed region is followed by a region where the coils are extended. Notice that the direction ng ating displacement of the coils is parallel. Okay, parallel to the direction of the propagation. Ano yung direction of propagation? Diba, ditulak na ng ating, itulak. Diba? So may force na nag-push. So yung ating compressed region along the spring, followed by a region where the coils are extended. Notice yung ating direction of displacement of the coils is parallel. Yung displacement of the coils is parallel to the direction ng ating propagation of the compressed region. So a longitudinal pulse along the stretched spring, the displacement of the coils is parallel to the direction of propagation. Okay. So next, a traveling wave or a pulse that causes the element of the medium to move parallel to the direction of propagation is called a longitudinal wave. So next is periodic wave. Under sa periodic wave ang ating sound waves. Sound waves are the most common example ng ating longitudinal waves. They travel to any material medium with a speed that depends on the properties of the medium. As the waves travels through air, the elements of the air vibrates to produce changes in density and pressure along the direction ng ating motion of the wave. Sound waves are divided into 3 categories that covers different frequency ranges. So under here is yung ating audible waves, infrasonic waves, and ultrasonic waves. So let's talk about yung ating audible waves. Yung audible wave natin, it lie between or it lie within the range of sensitivity of a human ear. So ito yung sound wave na naririnig ng mga tao. They can be generated in the variety of ways, such as by musical instrument, human voices, or loudspeakers. So again, ang audible waves, ito yung mga sounds na naririnig ng tao. Yung kayang ma-detect ng human ear. So sample nito, meron tayong musical instrument, and then yung sounds na napoproduce ng ating musical instrument is naririnig ng human ear or naririnig ng tao. So next is yung ating infrasonic waves. It has or it have frequency below the audible range. So ibig sabihin nito, yung ating infrasonic waves is hindi kayang marinig ng tao or hindi kayang marinig or hindi madidetect ng human ear. Pero yung mga elephants can use infrasonic waves to communicate with each other even though they are separated many kilometers away. So yung ating infrasonic wave is below 20 Hertz. So yung audible wave or yung kayang ma-detect ng human ear is between 20 Hertz to 20,000 Hertz. Okay. So next yung ating ultrasonic wave. It have frequencies above the audible range. So naririnig ito ng human ear, malakas lang. Malakas ito siya na tunog. You may have used a silent whistle to retrieve your dog. Ultrasonic waves are also used in medical imaging or yung ating MRI. Sample ng ating medical imaging using the concept ng ating ultrasonic waves. Isa din dito yung ating high frequency sound waves na ginagamit para ma-reflect yung baby tissues in the womb or makita yung image ng unborn child. Ginagamit ito sa mga ultrasounds. So, nakakita naman kayo yung mga produced picture na after magpa-ultrasound yung mga mothers. Okay, next. The sound waves. So, under sa topic na ito is i-determine natin yung speed of sound waves. So, speed of sound waves in a medium depends on the compressibility and density ng ating medium. So, here we have table 17.1. Ito yung mga common speed of sound in various medium or media. So, meron tayong mga medium na gases, liquids, and solids. So, under the gas, meron tayong hydrogen na may 0 degrees Celsius, meron siyang a speed of sound na 1,286. And same goes sa ating helium, which has a speed of sound waves sa 972. So, meron tayong air in 20 degrees Celsius, air in 0 degrees Celsius, oxygen, and then sa liquid, glycerol, seawater, water, mercury, kerosene, methyl alcohol, carbon tetrachloride. So nandito yung kanilang mga values. So if ever this will be part sa ating exam, this table naman will be provided sa ating test paper. Okay? So let's proceed dun sa mga formula na ating speed of sound. So meron dito yung mga representation under doon sa ating mga formula. So we have bulk modulus kung ang ating medium is naka-liquid or gas states. And then Young's modulus, it's solid. And then meron tayong rho. Ito siya, rho, ito siya. Ito yung ating density of medium. And then, nandito yung ating first formula ng ating speed of sound is equals to the square root of bulk modulus over the density of medium. Next is, if given ang ating elastic property and inertial property, ito yung ating gagamitin. So square root of elastic property over the inertial property. Next, if given naman is yung ating medium is naka temperature. Kumbaga yung temperature ng ating medium is given. So ito yung ating gagamitin na speed of sound formula. So is equals to 331 meter per second times square root of 1 plus T sub C over 273 degrees Celsius. So make sure lang na maging familiar tayo sa ating mga formula. And then dapat alam nyo kung saan sila gagamitin. So para hindi maulit yung nangyari ng midterm, kahit nandun na sa notes ninyo or nandun sa index card na yung mga formula, hindi nyo alam saan gagamitin. Nastanan na mo. Sayang lang. So here, yung ating formula in terms na meron tayong data na temperature, yung ating 331 meter per second, yan siya yung ating speed of sound in air na naka 0 degrees Celsius. And then yung T sub C naman natin is yung air temperature in degrees Celsius. And using this equation, one will find that a 20 degrees Celsius speed of sound in air is approximately 343 meter per second. Okay, so next, we will have our first problem. So find the speed of sound in water, which has a bulk modulus of 2.1 times 10 to the power of 9 Newton per square meter at the temperature of 0 degrees Celsius and the density of 1.0 times 10 to the power of 3 kilogram per cubic meter or 1,000 kilogram per cubic meter. So ano yung gagamitin natin na formula? Given yung ating bulk modulus, given yung ating density. So kahit may temperature na binigay itong ating problem, since given yung ating dalawang data para dun sa formula na speed of sound is equals to square root of bulk modulus over the density of the medium. So let's proceed. So yun na yung ating gagamitin na formula. So ang gagawin na lang is substitute yung mga data para makuha yung ating speed of sound in water. So here, yung ating answer for this solution or equation is 144.9.14. So ang kanyang unit is meter per second. Next, yung ating formula is, wait lang. Okay, so tandaan ha, 1,449.14 meter per second. Pero yung ating speed of sound in water, ang nakulangan lang itong problem, pero in terms of kilometer per second yung hinahanap. So ano ang ating value in terms of kilometer per second? So yung value kanina na 1,449 divide lang sa 1,000. So meron tayong speed of sound in water in terms of kilometer per second, may value na 1.4. Okay? So next. So, nandito. Kumbaga, ito yung ating controlled value. So pasok naman siya. So 1,493 meter per second. So kung i-kilometer natin, so 1.4 49 kilometer per second. So, malapit lang naman yung ating answer. So, in general, sound waves travel more slowly in liquids than solids. Kasi solids are more compressible. Yung liquids are more compressible than solids. Okay, let's do our problem number 2. Here we have dolphins use sound waves to locate food. Okay, experiments have shown that a dolphin can detect a 7.5 cm target 100 meter away, even in the murky water. For a bit of dinner at that distance, how much time passes between the moment the dolphin emits the sound pulse and the moment the dolphin hears its reflection or bumalik yung kanyang gi-emit na sound wave and thereby detects the distance target. So i-draw muna natin yung ating dolphin. So patawarin lang. Sandali lang. So sample. Okay. So may gi-emit sound pulse or sound wave. And then, nandito yung ating fish, yung kayang dinner. So yung distance nila is 110 meters. Okay. So nag-emit siya ng sound wave, it travels 110 meters. And then probably, para ma-detect yung kanyang dinner, is probably yung kanyang, wait lang, yung kanyang i-emit, diba? So, babalik. So once na balik the sound wave, dun niya na madedetect na merong fish ahead. So yung determine natin yung sound wave is times 2 ito. Kasi pumunta. And then bumalik. So, times 2 lang. Sandali lang, i-erase na natin. Series. So let's check the ating solution. So, okay. Solution. The total distance covered by the sound waves as it travels from dolphin to target and back, yun nga, 2 times 110 meters. So, meron siyang distance travel na 220 meters. So, kukunin natin yung time na bumalik dun, the time when yung dolphin nag-emit sa sound pulse and then nung na-detect yung target and then nagbalik yung sound pulse sa ating dolphin. So ilang minuto or how much time that does that the pulse travels back. So nandito yung ating formula. Delta T yung ating time. Delta X is the distance travel. And then yung B sub X is yung ating speed of sound waves dun sa ating medium. So ano ang ating medium? Since yung ating dolphin is makikita yan sa salt water, so yung ating medium is salt water. So yung ating gagamitin na velocity is 1,750. Okay. So yung ating 220. So divide lang natin yung velocity. Meron tayong delta T na 0.14 seconds. So it will take 0.14 seconds for the dolphin detects the fish that targeted fish kumbaga. Okay. So next, let's talk about transverse and longitudinal waves. Yung slower transverse waves, which is called X wave, but yung ating X is standing for stationary, it travels through the Earth 4 to 5 kilometers per second near the surface. So, ito yung ating representation ng ating sound waves. or sound waves, no, S wave or secondary wave. Okay? Next is yung ating longitudinal wave. Longitudinal waves are the fastest of the two. Kumbaga, mas mabilis yung ating P wave kaysa dun sa S wave and then dun sa surface wave. With P, which is standing for primary, kumbaga primary waves, because they travel faster than the transverse waves ng ating S wave, S wave at saka no, surface wave. And arrive at seismograph first. Yung ating seismograph, yan yung instrument na ginagamit to detect earthquakes. Okay, next. So, transverse waves, na-discuss na natin to kanina. Yung transverse waves is yung perpendicular motion or direction to the motion of propagation. Okay? So again, a traveling wave or pulse that causes element of disturbed medium to move perpendicular to the direction of propagation. Okay? So next is longitudinal waves. Again, na-discuss na to kanina. So, a traveling wave or pulse that causes the elements of medium to move parallel to the direction of propagation. So, this will be our last slide para sa ating PowerPoint, yung ating water waves. So, water waves are example of waves that involves a combination ng ating both longitudinal and transverse motion. Kasi as a wave travels through the water, the particles travels in clockwise circles or direction. So, ito. And then, the radius of the circle decreases as the depth into the water increases. Kasi, dito kumbaga yung dito sa upper part, yung motion is malakas. So, habang nagpalalim yung ating distance sa ating water or yung sa seawater, kumbaga, is yung movement ng particles is stagnant. So, wala tayong or yung movement ng ating water particle is slower. So, pahina yung ating waves. As deeper we go, nagiging at rest yung kung walang current, kung walang water current, nagiging stagnant yung ating medium, which is seawater. Pero hindi naman talaga stagnant. Kumbaga, lesser yung movement ng ating water particle. So, with that, yung ating video is natapos. Yung ating example for this problem, so here meron tayong example. Sa next video ko na siya i-present. So next video is part 2 ng ating wave motion, pero problem solving na tayo agad. Okay? So thank you for listening. See you again sa ating next video.